Hi everyone, Assalamualaikum. In this video, we will discuss Foundation of Applied Mathematics. We have 4 chapters under Foundation of Applied Mathematics. We done discuss chapter 1, Inverse Trigonometric Function in the previous video. So now, we continue with chapter 2, which is Hyperbolic Function and Inverse Hyperbolic Functions. Okay. In this video, we will discuss hyperbolic function first, right? Chapter 2, Hyperbolic and Inverse Hyperbolic Functions. Hope you enjoy and understand this video. Alright, now we look at what inside hyperbolic and inverse hyperbolic function. First, we discuss hyperbolic functions. Okay? Here are the list of topics under hyperbolic functions. Okay, topic 1, definition and identities of hyperbolic functions. Topic 2, proving the hyperbolic function using identities and definition. Topic 3, solving the hyperbolic equation using identities and definition. Topic 4, derivatives of hyperbolic function. And topic 5, integration of hyperbolic functions. Okay. In this video, we will discuss definition and identities of hyperbolic functions. Right? Alright. Now we look at the definition of hyperbolic function. Alright. Before we discuss further about hyperbolic function, first we look at trigonometric functions. Okay? Trigonometric function is about right angle triangle, right? From right angle triangle, sin x equals to A, which is opposite, over C, which is hypotenuse. Okay? And then number 2, cos x equals to B over C. B equals to adjacent and C equals to hypotenuse. Okay? And then tangent x equals to sin x over cos x, okay, which is opposite over adjacent, A over B. And then we have reciprocal function, set x equals to 1 over cos, okay. From cos here, we just exchange numerator and denominator. So we have C over B, okay. And then reciprocal function for sine, okay, is cosec x. Okay, cosec x equals to 1 over sine x, which is equals to, from sine x here, we just exchange numerator and denominator. So we get C over A. Okay, and then the last Rigaud ratios is cot x. Okay, cot x equals to reciprocal function for tangent, okay, which is 1 over tangent x. Or we can write cos x over sin x, okay? Or from tangent here, we just exchange numerator and denominator. So we get b over a. This is trigonometric functions. Okay, we have 6 functions, right? And trigonometric function based on right angle triangle. Okay, based on opposite, adjacent, and hypotenuse. Alright? Right, hyperbolic function are defined by exponential functions and occurs frequently in engineering and applied mathematics. Their behavior is similar to the cosine and sine function. Okay, first, we look at the first function under hyperbolic function. Okay, as I said before, hyperbolic function is defined in terms of exponential function. Okay, sinh x, okay, equals to e to the power of x minus e to the power of negative x over 2. Under hyperbolic function, we not use right angle triangle, but we base on exponential function. Sin h here, we read as sinh x or hyperbolic sine. Alright? So number 1, since x equals to e to the power of x minus e to the power of negative x over 2. Okay. And then formula number 2. Okay. Cos x or hyperbolic cos. Okay. Cos x equals to e to the power of x plus e to the power of negative x over 2. It is similar to sin, but in between here is plus sign. Alright? And then number 3, we have tan x or hyperbolic tangent, which is equals to sin x over cos x. Okay? Under trigonometric function, our tangent x equals to sin x over cos x. But under hyperbolic function, we have tan x equals to sin x over cos x. Okay? It looks similar, but if we have h here, we must use h also on the right hand side. Alright? And from sin x here, okay, we have e to the power of x minus e to the power of negative x over 2, and then over cos x, e to the power of x plus e to the power of x over 2, and after we simplify 2 here, so we get e to the power of x minus e to the power of negative x. Numerator is negative sign, and then denominator is positive sign, e to the power of x plus e to the power of negative x. Okay, this is tan x. Right? And then reciprocal function for cos x. Okay, sec x, or we can read as hyperbolic secant. Okay, sec x equals to 1 over cos x. Okay, since sec x is a reciprocal function for cos x, so we just exchange the numerator and denominator here. So we get 2 over e to the power of x plus e to the power of negative x. Okay? When we compare with trigonometric function, sec x equals to 1 over cos x. No h here. But under hyperbolic function, we have h here. Look similar, but under hyperbolic function must put h. Okay? Alright, and then reciprocal function for sin x. Okay, we have cosec x equals to 1 over sin x. Since cosec x is a reciprocal function for sin x, so from sin x formula, we just exchange numerator and denominator. So we get 2 over e to the power of x minus e to the power of negative x. Right? When we compare with trigonometric function, we have cosec x equals to 1 over sin x. No h here because this is trigonometric function. But under hyperbolic function, we must put h here. Okay? The function looks similar to trigonometric function, but we must put h. Okay? So cosec x equals to 1 over sin x. Okay? And cosec x also we can read as hyperbolic cosec. Alright? Which is equals to 2 over e to the power of x minus e to the power of negative x. Okay? And then the last one, cot x equals to 1 over tan x. Okay? Or we can write in terms of cos x over sin x. Okay? Since cos x is a reciprocal function for tan x, so we just exchange numerator and denominator. So we get cos x over sin x equals to e to the power of x plus e to the power of negative x over e to the power of x minus e to the power of negative x. Right? When we compare with trigonometric function, we still have 6 hyperbolic function. It looks similar to trigonometric function, but we have h here. Okay, h means hyperbolic, right? In trigonometric function, we base on right angle triangle. But in hyperbolic function, we base on exponential function. Alright? Right, from here, all hyperbolic function should be h. Okay, we must put h. It's similar to trigonometric function, but we must put h. Alright? Alright, how to calculate hyperbolic function using calculator? Okay, in calculator, we only have sine, cos, and tangent, which is trigo function. Okay, to evaluate hyperbolic function using calculator, we must use button HYP, which is stand for hyperbolic. Okay, so to calculate sin x, we must use hyperbolic sign. Okay, to calculate cos x, we must press hyperbolic cos. Okay, and to calculate tan x, we must press hyperbolic tangent. Okay, and then to evaluate the reciprocal function, we must first evaluate the basic hyperbolic function, and then we exchange numerator and denominator. Alright? Alright, now we look at identities of hyperbolic functions. Right? Many identities of hyperbolic functions are similar to trigonometric functions. Okay? So first, we look at what inside the identities of trigonometric functions. Okay? Alright, from trigonometric functions here, when we compare to hyperbolic function, it looks similar. But for hyperbolic function, we must have h. Okay? H stands for hyperbolic. Right? When we compare, it looks similar. Right? Alright, the first three we call as basic identities or Pythagorean identities. And then formula number 4, 5, and 6 we call as sum and difference identities. Right? Alright, the difference between hyperbolic function and trigonometric function for identities, we have negative sign here, minus in between. Okay, cos squared A minus sin squared A equals to 1. But under trigonometric function, we have cos squared A plus sin squared A equals to 1. No h because this is trigonometric function. Under hyperbolic function, we must have h. Right? And then identity number 2. We have 1 minus tan squared A equals to sec squared A. It looks similar to identity under trigonometric function, which is 1 plus. Okay, this is plus sign, this is minus sign. And then tangent squared A equals to sec squared A. No h because this is trigonometric function. Alright? And then formula number 3. It looks similar to formula number 3 under trigo function. But in between is minus. Okay? And then we must put h for hyperbolic function. Okay? So we have cot squared A minus 1 equals to cosec squared A. Right? For trigo function, there is no h. Okay? And then formula number 4. Okay. It looks similar to trigonometric function. Okay. And the sign also similar. Okay. Plus minus. And when we expand, we still have plus minus. Okay. Similar to trigo function. But for hyperbolic function, we must put h. Okay. So since A plus minus B equals to sinh A cos B plus minus cos A sinh B. Means that when we use plus sign, when we expand, we must use plus sign. When we use minus sign, when we expand, we must use minus sign. Right? Same, it looks similar to trigo function, but in trigo function, no h here. Right? And then formula number 5. Cos A plus minus B equals to cos A cos B plus minus sinh A sinh B. Okay, when we compare to trigo function, we have cos A minus B equals to cos A cos B minus plus sin A sin B. Means that when we expand cos A plus B, we need to use minus sign. When we use minus sign in bracket here, we must expand using plus sign. But under hyperbolic function, if we use plus sign in bracket, when we expand, we still use the same sign, means plus sign. And when we use minus sign in bracket, when we expand, we use minus sign also. Alright? And then formula number 6. Okay? Tan A plus minus B equals to tan A plus minus tan B over 1 plus minus tan A tan B. Alright? So, when we compare here, okay, it means that when we use plus in bracket, we must use plus plus on the top and bottom. Okay? But in trigo function, when we use plus in numerator, but we use minus in denominator. When we use minus in bracket, we use minus in numerator and we use plus in denominator. Okay? But under hyperbolic function, we have same sign. Means that when we use plus in bracket, all must plus. Okay? When we use minus in bracket, all must minus. Right? Alright, now we look at other identities of hyperbolic function. First, we look at trigo function. Under trigo function, we have double angle identities. Okay, we have 3 formulas here. Sine to A, cos to A, and tangent to A. But for cos to A, we have 3 formulas here. First, in terms of cos and sine. Second, in terms of cos only. And third, in terms of sine only. Right? Alright, under hyperbolic function, the formula looks similar to trigonometric function. Okay, formula number 1, we have sinh 2a equals to 2 sinh a cos a. It's similar to trigo function, but we have h for hyperbolic function. Alright? And then formula number 2, which is cos 2a. When we compare, okay, for cos 2x, in terms of cos and sinh, we must use positive sign here. But in trigo function, we have minus sign here. Okay? And then formula number 2 for cos 2x, when we compare with formula number 2 for trigo function, it looks similar. But under trigo function, no h. And under hyperbolic function, we must use h. And the sign are equal, means minus sign. Alright? And then formula number 3 for cos 2a. Okay? It looks similar to formula number 3 for cos 2a, but in between is plus sign, right? Plus, minus, plus. Alright, but under trigo function, minus, minus, minus. Okay, and then formula number 3, okay, for tanh 2a, okay, it is equals to 2 tanh a over 1 plus tanh squared a. We have plus sign here, but under trigo function, we use minus sign here and no h. Under hyperbolic function, we must use h, okay, and for tanh 2a, the denominator, we use plus sign here, okay. Alright, now we look at the other identities of hyperbolic functions. Okay. First, we recall back under reciprocal trigonometry identities. Okay, we have sine A equals to 1 over cosec A, or cosec A equals to 1 over sine A. And then we have cos A equals to 1 over sec A, or sec A equals to 1 over cos A. And then we have tangent A equals to 1 over cot A, or cot A equals to 1 over tangent A. Okay. Alright, now how about reciprocal hyperbolic identities? Okay. When we compare to reciprocal trigo identities, okay, it looks similar. Okay. But for reciprocal hyperbolic identities, we must put h, right? Since A equals to 1 over cosec A. Cosec A equals to 1 over sin A. Cos A equals to 1 over sec A. Sec A equals to 1 over cos A. Tan A equals to 1 over cot A. And cot A equals to 1 over tan A. Okay. This is reciprocal hyperbolic identities, and this is reciprocal trigonometric identities. Alright? But wait! Now we look at wrong way of writing in reciprocal function. Some student tends to write like this. Cosec A equals to 1 over sine, and then they put A here. Or cosec A equals to 1 over sin, and then they put A here. Okay? The correct way is cosec A equals to 1 over sine, and then we must put A beside sine. Okay, or cosec A equals to 1 over sin, and we put A beside sin. Okay, let me look at another example. Okay, tangent A equals to sine over cos A. This is wrong. Okay, or tan A equals to sin over cos, and then they put A here. This is also wrong. Okay, the correct way is tangent A equals to sine A over cos A. Okay, we put A beside sine and we put A beside cos. Okay, or tan A equals to sin A over cos A. We put A beside sin and we put A beside cos. Right? This is wrong. Okay, this is right. This is wrong. And this is right. Right? So, please be careful, okay? Never write like this, okay? The first row or the third row. This is wrong, right? So, this is the correct way to write a reciprocal function, right? Coming up next, proving the hyperbolic function using identities and definition. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.